Hi, this is Laura Wobozogan, your instructor this semester, and this video is going to be talking about Project 2, which is on earthquakes. So you can access this PDF or Word document in our Canvas course. And so we are going to be using Dataset 21, which is from the textbook's 13th edition. And it has a data set titled Earthquakes. We're using that data to complete our project. The data set includes the depths in kilometers and magnitudes of 600 earthquakes. Again, this is an individual project. Each student is submitting their own project solution. Project does need to be typed. Each part needs to be correctly labeled and completed in order. And again, explanations and work should be completed using the same method covered in our chapter notes and textbook. We will also be using StatDisk again, and the website is there. Distributions, which are our tables, can be created in Excel, Google Sheets, Google Docs, StatDisk, or Word. Points for each part are listed, and the total points that can be earned are 45 points. The difference between this and Project 1, which you'll notice is first we're dealing with a much larger data set here, 600 earthquakes rather than just 15 or 10 items in the last project. But you also notice that parts 1, 2, 3, 6, 7, 9, and 10 all required us to have screenshots of the output for StatDisk. So a lot more use of our statistical computer program, StatDisk. No points are rewarded for using a graphing calculator for those parts. So you do need to use StatDisk. Screenshots need to be legible and inserted into the project in the correct spot. You also must provide and clearly state specific answers. Make sure to round them correctly to 3 decimal places. And explanations need to be written in complete sentences. Show work for all calculations such as z-scores and outliers. The objective for this project is to gain knowledge of working with a statistical computer program. And then again, the distribution of data in the earthquakes does not need to be attached. It's very large. So first thing on here is that to access this data is a little bit different. We're not going to be actually typing it in. So at the very bottom of this project, you'll notice that it says, here's how to access the earthquake data on StatDisk. So we'll look at it together in just a moment, but you're going to go to Datasets, the drop down, and go to the 13th edition, that lucky number. And then from there, you're going to select Earthquakes, which is our Dataset 21. It is also typed down here to help. Again, if there's any questions, please reach out as soon as you have any problems. So going back up here to number 1. So number 1 says to find the mean and the standard deviation and the magnitudes of the 600 earthquakes. Use StatDisk. This is worth 4 points. We did do this in Project 1. Number 2 says to create a histogram of the 600 earthquakes magnitude. Use the auto-fit option for the class width and use StatDisk, also 4 points. We did a histogram also in our last project. What's new here is number 3, which is still also requiring us to use StatDisk, but this one wants us to create a normal quantile plot of the 600 earthquakes. So I'm going to go ahead and switch over to StatDisk so we can look at this. And you'll notice that I don't have any data yet in on StatDisk. So again, to do that, like it showed in the picture, Datasets, lucky number 13, the 13th edition, select that. And then if you scroll down, you'll notice that one of them does say earthquakes. It's our Dataset 21. Selecting that, it imports all that data, magnitudes and depths for those 600 earthquakes. And so again, for the first one that we have, number 1 on our project, it was asking for the mean and the standard deviation, which again was from exploring data. And you can select the column that we were going to use. We're exploring the data on magnitude, so definitely select that and hit evaluate. The second one was asking us to do a histogram, which we did before in the last project. So selecting histogram, you'll be able to give a title, label our x-axes and our y-axes on here correctly that fit with the data that we're using, which again is on the earthquake magnitudes. Definitely give it a title that's fitting also. What's new this time though is it does ask to use that auto fit option, and you will not need to enter in our class width or class start. That's not the option that we're using here. Then you would go to plot and create your histogram this way. Number 3 is new. That was asking for a normal quantile plot, and you can see that it's on here under data. Selecting normal quantile plot, you'll see that you are able to create a title, give the X label, And then the drop down here is selecting the column that you want to look at and then selecting plot to get our graph. So this is all 3 parts for the project, the first 3. Number 4 is asking, does it appear that the earthquake magnitudes are from a population having a normal distribution? Clearly explain and show all required work. It says in parentheses here to see section 6.5 for help. And when you look back at section 6.5, you'll notice that there's 3 things that need to be verified. Make sure you verify all 3 of those things. Number 5 says clearly check to make sure the requirements for using the t-distribution are satisfied in obtaining a 90% confidence interval estimate of the magnitude of earthquakes. Show all work and clearly explain. So if you go back and you look at your confidence intervals, you'll notice that there's certain things that had to be checked before we can even find those confidence intervals. So maybe it's a simple random sample or other things. Definitely go back into your notes to look at that. Number 6 and number 7 both require us to use StatDisk. They're very similar here. 6 says to find a 90% confidence interval, while a 7 says to find a 95% confidence interval. They both say the same thing though. So to find a confidence interval estimate of the mean magnitude of all earthquakes using the t-distribution, interpret your results and use StatDisk. So they're both 5 points. So going back to StatDisk, if you go down analysis, you'll notice that we do have confidence intervals on here, and it did ask about the mean. And since we're only dealing with one thing, the mean magnitude, I'm going to go ahead and select that. You have 2 options up here. You can either use summary statistics or use data. So again, summary statistics or use data. And it's easier if you use the data option. It does say the confidence level here. You'll notice it's automatically set at 95. One of those problems was asking for 90%, whereas the other one was asking for 95. So make sure to select it according to the part. Then from here, we can select magnitude or depth, again, depending on what the problem is asking for. The last thing on here says population standard deviation, but it does say if known, and we don't know that. So just go ahead and leave it blank and then hit evaluate. So again, that is for parts 6 and 7. Number 8 is asking for you to explain what happens to your confidence interval as the level of confidence increase. So again, use complete sentences to explain. Number 9 is saying using dataset 21 on earthquakes, find the probability, with that probability word being key here, that an earthquake will have a magnitude of 2.7 or larger. Use StatDisk to show all work. And so for this problem, you'll notice that when you hit analysis, here's probability distributions. Since that's what we're discussing here is probability, we are going to have a normal distribution, and when you go ahead and check those requirements in 6.5 or realize that our sample's over 30, we'll be able to use that normal distribution. From here, it's going to ask for a z-value, and you can go ahead and calculate that, or you can ask for the area from the left. This would be where you guys would use like inverse norm. And so in order to do this, you would have to be finding a certain value, like a magnitude that corresponds to a certain percentage. But we're asked about the probability, so definitely find that z-value and hit evaluate once you have it in. Again, that's using analysis, probability distribution, and that normal distribution that we have on here. If you don't feel it's normal and you feel like it's a student t-distribution, you can also do that. So to explore. And then the last thing that we have on here is number 10, which says, very similar to number 9, use dataset 21 on earthquakes. Find the probability that 25 earthquakes have a mean magnitude of 2.7 or larger. Use StatDisk and show all work. Very similar wording to number 9. The only difference is 9 has only 1 earthquake, whereas number 10 has 25 earthquakes. A great example to go back and look at in your notes is going to be the example that we did on Chevy Cobalts and kind of seeing the difference. And we also did another one on Coca-Cola. and seeing the difference between 1 Coke and 36 cans of Coke and how that changed that standard deviation. So again, this is our second project. If there are any questions, definitely reach out and ask. The Marks is also a great place to go and work since they have that computer lab. Best of luck and get an early start.